application of KVL, KCL, and node analysis and mesh analysis, or node method and mesh method. Okay, also we have seen some special cases of circuits where we can apply super mesh and super node. Okay, so next topic is network theorems. So we will first see why we use network theorems. What are the applications of network theorems? So network theorems are basically used to simplify the circuit further. Means how fast we can get our answer. Okay, how fast we can solve our circuit. So that is it will be very easy when we use network theorems. And what are the difficulties in the previous solutions that we are using for solving any circuit or network? So the difficulty when we talk about the node analysis and mesh analysis, so difficulty is that we have to write the equations based on the number of meshes or number of nodes, right? So if the circuit is complex where there are many equations, KVL equations or KCL equations based on the nodes and meshes. Okay. So if the circuit will be complex, we have to write several KVL and KCL equations, and that will be tedious tasks to solve those equations and to get the answer of parameters, means current or voltage. Okay, current in the loops, voltage at the nodes. So if the circuit will be complex, there are limitations of these solutions, that is node method and mesh method. Okay, so for the complex circuit, these methods are not quite suitable to apply. So that's why we are studying this network theorem. Okay, in while using network theorems, especially if we will use Thevenin's theorem, though the circuit will be very much simpler. We can solve very simpler way. Okay, so as we have seen in the previous class also, and in the the last time of the previous class, that I told about the network theorems and how many network theorems we have to study, and little bit about the introduction of these theorems. Okay, so we have to study about these all four theorems that I have written here, that is superposition theorem, Thevenin's theorem, Norton's theorem, and maximum power transfer theorem. So the specific condition is that these all theorems must be applicable for linear networks only. Okay, so these theorems are applicable to the linear networks only. They are not applicable to the non-linear network. So first you have to understand, and you have to tell why means what is the property of linear network. Which network is called as a linear network? Can you tell me what are the linear networks? I told you in the starting classes the difference between linear network. Hello? Okay, I am telling again, the linear networks means the network which has linear elements only. Linear elements, you know that the linear elements are those elements where there is a relationship, linear relationship between voltage and current. Okay. Suppose for passive elements, RLC, you know that there is a linear relationship between voltage and current. Okay, so the networks which contains passive elements, and or we can say the linear elements only, and they don't contain nonlinear elements, those networks are called as linear networks or linear circuit. Okay, nonlinear elements are diode, transistor, as I told earlier, that diode, transistor are in the category of nonlinear elements. So the circuit where diodes and transistors are there and the current is flowing through that diode and transistor in that circuits, these are nonlinear networks. So in nonlinear networks, these theorems are not applicable. Okay. So first we will see the superposition theorem. What is superposition theorem? So in superposition theorem, the statement is that in any linear bilateral RLC network, first you have to understand what is linear network, what is bilateral network, all these things you have studied. Okay. And RLC network. RLC means resistance, inductance, capacitance. The network having the passive elements resistor, inductor, and capacitor. Okay. So any linear bilateral RLC network, bilateral you already know that we can connect elements in any way, and if we are connecting in any direction, the property of that element should not change. Okay. So bilateral means the current can flow in both directions and the property will not change. So the circuit or network containing two or more independent sources. ओके, मीन्स दो या दो से अधिक अगर इंडिपेंडेंट सोर्सेज होंगे किसी भी नेटवर्क में और किसी भी सर्किट में, दैट इंडिपेंडेंट सोर्सेज आर वोल्टेज और करंट सोर्सेज or combination of voltage and current sources. Okay, so the resultant current and voltage in any branch is the algebraic sum of currents, voltages caused by each independent source acting alone. Okay, with all other independent sources being replaced by their internal respective internal resistances. So we are talking about the independent sources. Independent sources are current and voltage. We know that there are two types of sources, current and voltage sources. So in any circuit or network, if there are more than two independent sources, they can be voltage or current sources. So the resultant current or voltage in any branch that we have to find out is the algebraic sum of current or voltages caused by each independent source acting alone. Okay, means at a time we have to take one source and we have to eliminate other sources or disable other sources. How we can disable? We can replace those sources by their internal resistances. Okay, if they are ideal sources, if they are ideal sources, you know that for voltage source, ideal voltage source, the internal resistance is 0, right? And for ideal current source, internal resistance is infinite. So for ideal voltage and current sources, they will be replaced by their internal resistance, means it will be replaced by resistance 0 and replaced by resistance infinite. Okay, so resistance 0 means short circuit, resistance infinite means open circuit. So that's why, assuming the ideal sources, generally replacement of the independent sources as follows. All other independent voltage sources are short circuited. Independent current sources are open circuited. All dependent sources will be remain as they are, means they will neither short circuited or open circuited. Clear? Is it clear to all of you how we are replacing the sources? You have studied about voltage source and current source. Okay, So the property of that voltage source and current source we are using. So if there is any doubt, tell me. In this theorem, to apply this theorem, we have to take one source at a time. Okay, and we have to eliminate other sources. And how we can eliminate or disable? Voltage sources will be short circuited, current source will be open circuited. Why voltage sources are short circuited? Because the voltage sources will be replaced by their internal resistance, and you know that for ideal voltage source, internal resistance is 0. So that's why it will be replaced by 0. 0 means short circuit. Okay. Resistance 0 means voltage will be 0. So it will be short circuited. Resistance infinite for independent current sources, ideal current sources. So that's why resistance infinite means open circuit. So current sources will be open circuited. If there are any dependent sources in the circuit, we don't have to touch the dependent sources. They will remain as it is in the circuit while solving. Clear? Is it clear to all of you? Hello?
Yes, sir.
Okay. So we will see how we can solve. The procedure is that in step 1, we have to take one source at a time. So retain one source at a time in the circuit and replace all other sources with their internal resistances. If they are practical sources, if voltage and current sources are practical sources, so in the problem itself, you will find the values of internal resistances. So you have to replace those sources by their internal resistances. Okay. Then we have to determine the output, that is voltage or current value, due to single source acting alone using the technique discussed earlier. That is, you can use either KVL, KCL, mesh analysis or node method. Okay. Repeat step 1 and 2 for each of the other independent sources. Means we have to consider one source at a time and we have to solve the circuit and we have to find out the current or voltage which was given to us. Okay. And in step 4, we have to find the total contribution by the adding algebraically all the contribution due to the independent sources. Means ultimately, suppose if we have to find the current through any branch, so we will find out the current through any branch by considering each source at a time. So suppose one source we are taking and we are denoting the current I1. Another source we are taking, we are denoting current I2. Another source we are taking that third source and we are denoting current I3. So I1, I2, I3 we have to calculate by taking individual sources at a time and by replacing other sources with their internal resistances. Okay. If they are ideal sources, voltage sources will be replaced by short circuit, current sources will be replaced by open circuit. Clear? So the overall circuit will be very easier to solve. Then after calculating the values of I1, I2, I3, we have to add all currents algebraically and we have to find out the resultant current value. That will be your final current flowing through that branch. Okay. So this is a just simple procedure. This is an example where we have to apply the superposition theorem. So in this problem, in example 1, consider the network shown in figure 1, calculate IAB and VCG using superposition theorem. This is IAB, current flowing through this R2 resistor, and VCG, voltage across this current source VCG. So where we have to find out the value of VCG, and that will be this value. Okay, VCG means this will be plus, this will be minus. Okay, so how many sources are there? How many independent sources are there in the circuit?
Two.
Two, yeah. One voltage source, another current source, right? So for the simplicity, we have taken only two sources in the circuit. This one is voltage source and this is current source. So there are two sources in the circuit. As per the superposition principle, we have to consider one source at a time and we have to calculate the values of desired current and voltage. Okay. So considering the voltage source only, the first step is retain one source at a time. So we are in first step, we are taking this voltage source only and we have to eliminate this current source. So how current source will be eliminated? As per the definition and as per the principle, you know that the current source, ideal current sources will be replaced by their internal resistance, that is infinite internal resistance. So infinite internal resistance means there will be
Open circuit.
yes. So this current source you have to open circuit. So in figure 2a, you can see that taking voltage source 3 volt only, you can see the term in this between two terminals, the current source was connected and we have kept open circuited. Okay. So in this case, we have to calculate the values of IAB. This is IAB. So we can consider this as a IAB dash. Okay. And we have to calculate by considering the remaining circuit. Clear? So you can use any method to solve the circuit and you have to find out the value of IAB and VCG. So R equivalent is equal to RAC, RCB, RAC and RCB. These two are in series combination. You can see clearly these two are in series combination. While opening these two terminals, these 3 ohm and 4 ohm, they will be in series combination because same current will be flowing through both 3 ohm and 4 ohm. So series combination will be 7 ohm and parallel to that 7 ohm is RAB. RAB is 1 ohm. You can see that if you will simplify this in between these two terminals, this is the parallel. Okay. So 7 ohm is parallel to the 1 ohm. And then if you resolve the circuit, this will be in series with this parallel combination. Okay. So plus RBG. So equivalent resistance will be 23 by 8. So 23 by 8 is the equivalent resistance. 3 volt is the voltage source value. So what will be the current flowing through this source? The current flowing through this source I will be equal to 3 divided by 23 by 8. 3 divided by 23 by 8. That will give you 24 by 23 ampere. That is 1.043 ampere. Okay. So the current through AB, we have to ultimately identify current through AB. If you simplify the circuit will look like this is a voltage source, this is resistance. this is resistance, this is also a resistance, and the parallel combination, series combination of these two, this is 1 ohm, this is 2 ohm, and this is 7 ohm, this is 3 volt. Okay, and from here 24 by 23 ampere is flowing. So this current will divide in these two branches. We have to find out this current IAB dash. This is A, this is B, okay, and this is G. So we have to find out this IAB dash. This 24 by 23 ampere current is flowing through this voltage source, and it will divide in these two branches. So how we can divide this current?
Inverse ratios of resistance.
Yes, there is a current division rule. So current division rule, in the current division rule, suppose there are two resistances, current flowing is I, this is R1, this is R2, current flowing in R1 will be I1, here I2. Means main current I is dividing in two parallel branches R1 and R2. So here I1, current flowing through this R1 is I1, current flowing through this R2 is I2. So as per the current division rule, I1 will be equal to I into R2 divided by R1 plus R2. And similarly, I2 will be equal to I into R1 divided by R1 plus R2. Clear? If you'll add these two currents, you will get simply I. So because at this node, if you'll apply KCL, I will be equal to, by applying KCL at this node, I will be equal to I1 plus I2. Okay. So I1 is equal to I into R2 divided by R1 plus R2. I2 is equal to I into R1 divided by R1 plus R2. It means if you are calculating the current flowing through this R1, okay, in the numerator you have to take opposite value of element, and in the denominator the sum of both will be there, R1 plus R2. So similarly, if you'll apply KCL, if you'll apply this current division rule to calculate the value of IAB dash, so what will be the value of IAB dash? IAB dash will be equal to main current 24 by 3 ampere. It is dividing in two paths. So 24 by 23 multiplied by, which one we have to keep in the numerator? किसको न्यूमरेटर में रखना पड़ेगा? IAB डैश हमको फाइंड आउट करना है करंट फ्लोइंग थ्रू दिस 1 ओम रजिस्टर. ये दोनों
7 ऊपर
यस,
और
ये दोनों पैरेलल में है.
7 प्लस 1 नीचे.
हाँ, 7 डिवाइडेड बाई 7 प्लस 1. क्लियर? सो इतना करंट आएगा IAB डैश, राइट? सो द करंट थ्रू AB IAB will be equal to 7 by 8 multiplied by 24 by 23. This is 7 by 8 only. 7 by 8 into 24 by 23. That is 0.913 ampere. And it is coming due to the voltage source only, by considering voltage source only. Okay, this is the first step. In second step, also we have to calculate the voltage across CG terminal. So voltage across CG terminal VCG will be equal to VBG plus VCB. VBG plus VCB. Okay, so we have to calculate the value of voltage also, plus minus VCG. So VCG will be equal to, because the current I is flowing through this direction, so here the current will be there. Here in this branch current will be in downward direction. So we have to calculate the value of current flowing through this branch also, means current flowing through this 4 ohm resistor. So we have calculated IAB dash is equal to 24 by 23 into 7 by 8. So 21 by 23. Okay, and from here the main current flowing is, कितना current flow कर रहा है, 24 by 23. Okay, so what will be the current flowing through this branch 4 ohm?
माइनस कर दो।
कितना हो जाएगा, दिस माइनस दिस ना.
यस सर।
यहाँ पे KCL अप्लाई करेंगे तो I इज इक्वल टू दिस करंट IAB डैश प्लस इसको IAC लिख देते हैं, IAC डैश प्लस IAC होगा. सो IAC इज इक्वल टू I माइनस IAB डैश. सो I माइनस IAB डैश मीन्स this IAC will be equal to 24 by 23 minus 21 by 23. That will be 3 by 23 एम्पियर. सो यहाँ पे 3 by 23 एम्पियर आएगा, 3 by 23 एम्पियर. इसमें करंट कितना आएगा 2 ओम में?
सर IAB क्या है?
IAB करंट फ्लोइंग थ्रू दिस 1 ओम रजिस्टर.
और IAB डैश?
अरे उसी को IAB डैश, यहाँ पे डैश नहीं लिया है, हमने ले लिया है. ठीक,
हाँ वही वो कंफ्यूज.
नहीं कंफ्यूजन नहीं रखना है. IAB dash we have taken because same IAB we have to calculate by considering this current source also. Okay, so that's why it will be IAB dash. Second time, if we consider the current source only, we will take this IAB double dash. Okay, so what will be the current flowing through this branch 2 ohm resistor?
24 by 23.
4 by 20.
Okay, by applying KCL at this point B, this is incoming current, this is also incoming current, both current will be added na at this point. So 24 by
Yes
20,
sir.
24 by 23 plus 3 by 23, 27 by 23 यहाँ से जाएगा, है ना, 27 by 23, right?
सर जो इनिशियल करंट जो जा रहा है वही लौटेगा ना, तो इनिशियल तो 24 by 23 जा रहा है.
ओ सॉरी यस, यहाँ पे ये मैं एक्चुअली 24 by 23 समझ गया, ये 21 by 23 है ना IAB डैश,
यस सर.
21 by 23. सो ये 24 by 23 ही जाएगा, जो करंट यहाँ से निकलेगा वही करंट इसमें वापस आएगा. सो 24 by 23 ही होगा. (24 by 23 ampere). Okay, so the voltage drop will be the current flowing through this terminal. So क्योंकि ये एलिमेंट है, सो इसके क्रॉस वोल्टेज ड्रॉप अगर डिनोट करना है तो प्लस यहाँ करेंगे,
Sir, you're not audible.
Recording stopped.
Okay, so there was internet issue, and similarly, together with the power issue was also there. Due to that, internet issue was there. So I was disconnected for some time. So can you hear me now?
Yes, sir.
Yes, sir.
Recording in progress.
So we were discussing about the solution of this. Okay, so we have evaluated the current flowing through this branch, and the current flowing through this branch, how much was there? 3/23, as I remember. And the current flowing through this branch was 24/23, right? Okay. And we have to calculate the voltage between these two terminals, VCG. So if we apply KVL in this loop, we can be able to calculate the value of VCG. Okay. So the current flowing is from C to B. So that's why the polarity across voltage drop polarity will be plus here, minus here. Means in the element, we know that in the element current will flow from higher potential to lower potential. That's why plus will be here, minus will be here. Similarly, in this branch also, plus will be here, minus will be here. Is it clear to all of you?
Yes, sir.
Okay, so if we will apply KVL in this loop, so by applying KVL, if we start at this point, we will take this VCG and then voltage across this branch, then voltage across this branch, and we will reach at this point again. So minus to plus we are going, so we will take plus VCG, then plus to minus we are going, so we will take minus of 4 into 3/23, then plus to minus again, so minus of 2 into 24/23, that is 0. So VCG will be equal to 12/23 plus 48 by 23. Okay, so VCG, you can see that it is 2 into 1.403, that is nothing but this is 24 by 23, 2 into 24 by 23 plus 4 into 3 by 23. 4 into 3 by 23 is 0.13, 0.13. So ultimately you will get 2.61 volt by considering voltage source only. Clear? So now in the second step, we will take current source. So considering current source only. Now in this case, the current source we have taken, we have eliminated this voltage source. And as per the rule, you know that the voltage source, independent ideal voltage sources will be replaced by short circuit. Okay, so voltage source will be short circuited, then the circuit will be like this. Okay, now how we can resolve this circuit? You can see that this terminal and this terminal is same. These two terminal are same. 1 ohm is here, 2 ohm is here. So both will be in parallel combination, right? This resistor and this resistor both will be in parallel combination. Is it okay? So if we rewrite the circuit, this is 1 ohm, this is 2 ohm, both will be in parallel, and in between B and C, this is a 4 ohm resistor. In between B and C, 4 ohm resistor is there. This is 2 ampere current source. And then 3 ohm is connected between C and G. In between C and A or G, both are in the same potential. So in between C and A or G, this 3 ohm is connected. So if we rearrange the circuit, so the circuit will be look like this much. Okay, and in this branch across the 1 ohm resistor, you have to find out the current value. So it is nothing but IAB double dash. So IAB double dash we have to find. Okay, these two are in parallel. This is in series with that parallel combination, and this will be also in parallel. Okay, so in the following branches, 3 ohm resistor, the current flowing will be in 3 ohm resistor, the current flowing will be 14 by 3 into 3 divided by 14 by 3 plus 3. It means that the parallel combination of these two is 1 into 2 divided by 1 plus 2, that is 2 by 3 plus 4 plus 4, that will be 14 by 3 ohm. So if you'll resolve this circuit, so the circuit will be look like this circuit. The current is 2 ampere. This is 14 by 3 and this is 3 ohm. Okay, so we have to calculate the current flowing through this IAB double dash, but we have to calculate the voltage across this CG also. So for that we are calculating this current in 3 ohm resistor. So current in 3 ohm resistor will be equal to 14 by 3. This will be in the numerator
Sir,
into 2.
where did you get this 14 by 3 from?
14 by 3 is the parallel combination of these two, 1 and 2. Okay.
Okay, sir.
And this is in series with that. So 1 into 2 divided by 1 plus 2, that is 2 by 3, and 2 by 3 plus 4. Okay, this is in series.
Okay, sir.
2 by 3 plus 4 is 14 by 3 ohm. So this whole series parallel combination is resolved in the single resistor, and the equivalent resistance value is 14 by 3 ohm, right?
Okay, sir.
Now we have to calculate the current flowing through this 3 ohm resistor. Also, we will calculate the current flowing through this 14 by 3, so that we will divide at point B and we will get the value of IAB double dash. Okay. So current flowing through this 3 ohm resistor will be equal to 14 by 3, that will be in the numerator, multiplied by the main current 2 ampere divided by 14 by 3 plus 3, right? So this will be the current flowing through 3 ohm resistor. So the current flowing through this 4 ohm resistor, that will be equal to 2 minus 1.217. Means if this is 1.217 ampere, so this will be 2 minus 1.217, right? So you will get 0.783 ampere. So 0.783 ampere is current flowing through this resistor, 0.783 ampere. And the same current will divide in these two branches, parallel branches. So again here at this node you have to apply the current division rule. Okay. So current flowing through this 1 ohm resistor, that will be IAB double dash is equal to main current is coming 0.783 multiplied by, इसमें निकालना है तो इसको न्यूमरेटर में रखेंगे 2 divided by 2 plus 1, that is 2 divided by 3. So 2 by 3 multiplied by 0.783, that will give you 0.522 ampere. And the current is flowing from B to A. Okay, current flowing from B to A. So in this case, we have to calculate the voltage across CG also, CG terminal. So voltage across CG terminal will be this resistance multiplied by the current flowing through this branch. Current flowing through this branch is 1.217 ampere. So 3 multiplied by 1.217 ampere, and current flowing is downward. So the polarity will be plus here, minus here. Okay, voltage drop will be plus here, minus here. That will be exact voltage polarity of CG that we have assumed. So it will be 1.217 multiplied by 3, that is 3.6151 volt. Clear? So now we have to take the algebraic sum of both currents and voltages. Okay, so algebraic sum of currents we can see in the previous diagram when we are considering single voltage source. So in that case, the IAB is the current flowing from A to B. Okay, IAB double dash, IAB dash is the current flowing through from A to B. Okay, 0.913. Now in this case, you can see that the current flowing is coming from B to A. Okay, so the resultant current will be A to B 0.913, from B to A it is 0.522. Okay, so algebraic sum will be, the resultant current will be from A to B, because if the current flowing is from A to B, the current value is higher than B to A. So that's why we have to take this negative sign, and while algebraic sum we will take 0.913 minus 0.522. So that will be 0.391 ampere, the final current. Okay, that will be flowing through this branch IAB in the actual circuit. Okay, now we have to calculate the total voltage across current source VCG. Due to voltage source, we have obtained the value VCG is 2.61 volt. Due to current source, we are obtaining 3.651 volt, and both are positive sign. Okay, so that's why they will be added. So 2.61 volt plus 3.65 volt will be 6.26 volt. That will be ultimate your answer. Clear? Is it clear to all of you? Means
Yes, sir.
in superposition theorem, we can obtain the current flowing through any branch or voltage across any two terminal. Okay. So I am giving you a task as a homework that you can take this circuit diagram. Okay. In the previous node analysis and mesh analysis, simple node and mesh analysis, we have taken this example, right, where we have taken two voltage sources. So you have to take the same circuit and you have to apply superposition theorem, and you have to get the voltages and the current flowing through all branches. Okay, and that the current value you have to validate whether we are getting the same current value or not in superposition theorem, right? So this is for your homework. Means the circuit you can note this one. This is a voltage source 20 volt. Then three resistances are connected, each value of 5 ohm, and this is a 10 volt source. Okay, so that direction you have to take and you have to solve. This is for your homework, and also you have to solve this example too together with the previous problem. So these two problems are for your homework. Then we will move towards the next network theorem. So the third example you have to note down. I am rewriting the same circuit that I was given for simple mesh and node analysis. So I am rewriting the same circuit. This is 20 volt. This is 10 volt. 5 ohm. 5 ohm. 5 ohm. Okay. You have to calculate, you have to evaluate the current flowing through all branches. Okay. Means you have to calculate I1, I2, I3 values. This is your task. This is your homework. You have to apply superposition theorem only. Okay. Is it clear?
Yes, sir.
And together with you have to solve this example number 2 also. You have to solve completely and you have to find out the values of I1, I2, I3, I4 in this method. Okay, superposition theorem. Okay, so now I will take your attendance. Ashish Chandra, Avya,
Present, sir.
Aditya,
Present, sir.
Akash Srivastav,
Present, sir.
Akhilesh Sahu, Akshit Taneja,
Present, sir.
Anand Kumawat,
Present, sir.
Ankit Das,
Present, sir.
Apurva Raj,
Present, sir.
Arnav Kumar,
Present, sir.
Avinash,
Present, sir.
Ayush,
Present, sir.
Gaurav,
Present, sir.
Ishant,
Yes, sir.
Krishna,
Yes, sir.
Maitri,
Present, sir.
Mudra, Paranjay,
Present, sir.
Prachi, Prajwal, Prachi. Okay.
Present, sir.
Hmm. Okay. Priyansh,
Yes, sir.
Priyanshu,
Present, sir.
Pulkit,
Present, sir.
Rahul, Rajiv Kumar Pandey, Rishabh Arya,
Present, sir.
Rohan, S. Ritik Sai,
Present, sir.
Saket Suman,
Present, sir.
Samyak,
Present, sir.
Sangram Chakrabarti,
Present, sir.
Sasank Tripathi,
Present, sir.
Shubham Ranjan,
Present, sir.
Shubham Singh,
Present, sir.
Srajan,
Present, sir.
Sudhanshu,
Present, sir.
Sujit, Sumit, Supriya,
Present, sir.
Suryansh,
Present, sir.
Ujjwal,
Present, sir.
Utkarsh,
Present, sir.
Vaishnavi,
Present, sir.
Vedanshi,
Present, sir.
Vishal,
Present, sir.
Yash,
Present, sir.
Vinita,
Present, sir.
Sambhavi, Sambhavi Srivastav. So you can see your attendance here.
Hello, sir.
I will update on yesterday lecture attendance. I have not updated yet. Yeah, you can tell.
Sir, my name is Ayush Kumar Singh. I was present all day on 14th also. It is not written here on 14th.
Recording stopped.
What is your name?
Ayush Kumar Singh, sir.
Ayush Kumar Singh. Ayush Kumar Singh is not there.
On 12th, sir. 12th.
12th, yeah. Ayush Kumar Singh.
On 14th, sir.
14th you are there?
Yes, sir. Every day I am present.
I think you didn't tell your name. Attendance.
Sir, my name is Mayank. Sir, please mark my attendance.
Mayank.
Yes, sir, Mayank Sharma.
Mayank is not there. Have you joined late?
No, sir, my connection got lost. I joined.
So, Mayank.
Yes, sir, Mayank Sharma.
Mayank. 24 IT. There are two IT students at the name of Mayank. M-A-Y-A-N-K.
No, sir, I belong to sir electrical department.
What is your exact name? M-A-Y-A-N-K.
Mayank Sharma.
M-A-Y-A-N-K, right?
Yes. Yes.
It is not coming.
Sir, this is electronics class, na? He is from electrical.
EV.
EV, yes, sir.
So you have to join this EV branch class. Okay, this is only for electronics student.
Hello,
So
sir.
please mark my attendance. So I also lost my connection. So
What is your name?
Achilles Sahu, sir.
Sir, I was present in every class, but at starting there wasn't mark.
What is your name?
Sir, Suryansh Verma.
Suryansh Verma. Suryansh Verma. So you didn't tell in the starting classes attendance. Why?
Sir, I thought my mic wasn't working at that time.
Okay, no issues. While when we will come here, I will update. Okay.
Okay, sir.
The same for me too. I was. Sir, hello, sir. So my attendance on 18th and 21st are not marked while I was there. I made an absent on 19 and 22. but it was not marked. My name is Krishna Gupta.
Okay, no issues, no issues. If you are were present while when you will come here in offline mode, okay, you have to show your attendance there. Okay, no issues.
Okay, sir.
Hmm. Okay, so then we will again meet in the next class tomorrow. Okay, thank you.
Thank you, sir.
Thank you.